Hi everyone, Miss Lorette here. I'm going to be walking you guys through section 2.10, which is change expressed as a percent. Go ahead and grab your notebook, something to write with, as well as a calculator, and let's dive right in. Now, before we can talk about how to calculate change expressed as a percent, we need to do some review here on how to convert a number into a percentage because we'll need to use this skill in the formula for percent change. So we've got a fraction here and a decimal. Hopefully you've learned in a previous lesson, if you don't have me as your teacher, on how to take any number and represent it as a percent. So go ahead and pause the video, see if you can come up with some answers here, and then we'll go over it. Okay, so hopefully you've given that a go. We've got a fraction, 13 over 40. There's a couple different ways that you can represent this as a percent. You can set up a proportion where you've got some variable over 100 and then solve for what that percentage would be. Or what you could do is you could make this into a decimal, because we're going to have to convert this decimal anyways. You can make this into a decimal and convert it the same way that we're going to do over here. So to make 13 over 40 a decimal, I simply divide 13 by 40, and I'm getting 0.325. And I can take this decimal, and if you recall, the definition of a percent is that it's some number out of 100. So if I multiply this decimal by 100, that's going to give me my answer in percent format. The easiest way to know what we're going to get here if we multiply by 100 is I take this decimal point and I move it 2 places to the right. So if I multiply by 100, this is going to be 32.5%. And I can do the same thing for this decimal here. I can take this decimal, multiply it by 100. That's the same thing as taking the decimal and moving it 2 places to the right. So 0.0541 is the same thing as 5.41%. So if you understand that to go from a decimal to a percent, we just multiply by 100, then that will clear up part of what we do when we find percent change. So for percent change, we follow a formula. The formula is amount of change we divide that by the original amount. And then to represent that as a percent, just like we did before, we would divide here, possibly get some sort of decimal, and then multiply that by 100. And that's gonna, this part here, this multiplying by 100 will change that number into a percent format. It's also important to note that when we find amount of change, we're subtracting, right? And we always want to subtract in such a way that we get a positive number. So the amount of change, let's add some notes here. Amount of change. To find this, we're going to subtract in such a way that we get a positive difference. So for example, if you knew that the sale price of a shirt was now $40 and the original price was $50, you can actually use this formula to figure out what was the percent discount. But you'll always want to subtract to find the amount of change. So if I wanted to find the amount of change, I would do 50 minus 40, and that would give me 10. And I would always subtract in such a way that I get a positive answer. So thinking about it the other way, if we were selling a shirt and we were marking that price up, let's say that shirt was $20 and we were marking the price up to $30. I wouldn't do 20 minus 30, even though 20 is the original price. I always subtract so that it's the bigger number first I subtract the smaller one, and then I use that in my formula, because we always represent percent change as some sort of positive value, regardless if it's a percent increase or decrease. And a percent increase is exactly what it sounds like. If you've got some new amount, the new amount, and it's higher than the original, it's a percent increase. So the new amount is higher than the original. So for example, if I was marking up something that I was selling in my own store, that would be a percent increase, because the new amount that I'm charging for that item is going to be higher than the original price that I paid for it if I'm the owner of a store and I'm selling something. If I'm a consumer and I buy something on sale, that's an example of a percent decrease, where the new amount is lower than the original. So hopefully that's just kind of common sense. If the new amount is higher, it's a percent increase. If it's lower, it's a percent decrease. So we may come across questions where we're asked to identify what type of percent change it is. Was it an increase or a decrease? We can simply look at the two values that were given and see if the value went up or down. So let's do an example here, and we're explicitly told that this is going to be a percent decrease, so we don't have to provide that part of the answer. It says a coat is on sale. The original price is $82. The sale price is $74.50. What is the discount expressed as a percent change? So in previous problems, we were given the percent change and we had to find this part. We had to find the selling price. Here it's the other way around. We're given the selling price and we want to know, what was the discount? How much was it on sale for in terms of a percent? So to do that, we're going to use our formula, amount. I'm just going to abbreviate, amount of change divided by the original amount, and we're going to multiply that by 100 to make it into a percent. Now again, we always find the amount of change by subtracting the two numbers that we see, but we want to always subtract so that our difference comes out as a positive answer. So I'm going to take the bigger number here, and I'm going to subtract the smaller one. And if I do that, and I'll just use my calculator here, 82 minus 74.50 gives me 7.5. So here's my amount of change. Now I'm going to take that amount of change and divide it by the original amount. Here's the original. Okay, it's always the first value that we're given. Well, not always the first value, but it's always the first value in the context of the problem. So this coat, the first price was $82, but the sale price, the new price, was $74.50. So this first price here, the original price, that's my original value, which will go in the denominator of my fraction here. So I'm going to take 7.5 and divide it by 82. And then whatever I get, I'm going to multiply that result by 100. So at this point, it's kind of like just following order of operations. I divide and multiply left to right. So I'm going to divide 7.5 by 82. It's giving me a non-terminating decimal. So what I'm going to do is, before I clear that from my calculator, I'm going to take that result and multiply it with 100, and I'll round last. So I'm going to say for this video, I'm going to round to the nearest tenth of a percent for any problem where we get a decimal that doesn't terminate. So after multiplying by 100, I'm getting 9.146, and so on. It just keeps going. So if I want to round to the nearest percent here, or excuse me, the tenth place of a percent, I'm going to round the 1. So I look next door. If that value is 4 or less, I'm going to let that 1 rest. So it's 9.1%. Here's the discount. It was a 9.1% discount. So here's a similar one for you to try. I'm gonna pause the video here and let you give it a go. And when you unpause, you should see a solution. Okay, so here is what I am getting for my answer. I'm getting approximately rounded to the nearest tenth of a percent, 31.7%. So it said the average monthly precipitation for Chicago, Illinois peaks in June at 4.1 inches. The average monthly precipitation in December is 2.8 inches. So June comes before December, so we can assume that this 4.1 is the original amount. And we want to know what's the percent decrease from June to December. So this is our formula. We're going to subtract the 2 inches to see what the amount of change is, and always subtract so that we get a positive. And then we're going to take that 1.3 and divide by the original amount, which was 4.1. We're going to divide first. It's going to give us a decimal. I'm going to take that decimal and multiply by 100, and it gives me this as a percentage. So I just kind of write a few decimal places before I round it. And again, I just rounded to the nearest tens place. Your teacher may have different specifications for where they want you to round, so always just double check. But for this lesson, I'm just going to round here. The 0 to the right told me to let that 7 rest. So that was my final answer. Let's do another one. So in this one, we're explicitly told that this is a percent increase. So the new amount is going to be higher than the original. A store buys an electric guitar for $295. Then the store marks up the price to $340. So here is the original price. And then that's the new price after it was marked up. What is the markup expressed as a percent change? So again, my formula is amount of change divided by original times 100. To find my amount of change, here, instead of doing original minus new, I want to do it the other way because I want to subtract so I get a positive. So be careful here. 3 minus 295 will give me a positive amount of change, which is 45. So here's my amount of change. Then I'm going to take this 45 and I'm going to divide it by the original. The original was 295, and then I'm going to multiply that result by 100. So I'm going to take 45 divided by 295. Again, I'm getting a decimal that doesn't stop. So before I clear my calculator, I'm just going to take that result and multiply by 100. And depending on the kind of calculator you have, you might be able to do both of these operations at once. I'm getting 15.2542, and it just keeps going. Again, this is percent format since we multiplied by 100, but I'm going to round that to the nearest tenth. So I'm looking at the 2. The 5 tells me to raise the score. If it's 5 or more, raise the score. So this is going to become a 15.3%. Here's one for you to try. Again, I'll pause the video here, give it a go, and then when we unpause, you should see a solution. Okay, so here's what I'm getting as my answer. In 1 year, the toll for passenger cars to use a tunnel rose from $3 to $3.50. What was the percent increase? So $3 was what it originally was, so that's our original amount. I'm going to write my formula and then find the amount of change by subtracting. And again, I always start with the bigger number, so I get a positive value. We shouldn't get any negative numbers for our answers when we're doing percent change. When I subtract, I get 0.5. I take that 0.5, divide it by the original price, which was $3, multiply that by 100 to make it a percent format, and I just round it to the nearest tenth. So I'm looking at the 6 that I'm underlining and then using the number next door to the right to help me round. If it's 5 or more, we raise the score so it becomes a 0.7. So as you guys can see, it's a very rinse and repeat method that we're using here. It's the same process every single time. Another way that you might see questions asked for percent change is in this format, where it's telling you from some value to another. the first value that you see, you always assume is the original. So it says find each percent change, state if it's an increase or decrease. So we're doing two things for each of these questions. Not only are we finding the percent change, but we also have to state whether it's a percent increase or decrease. And then we're going to round to the nearest tenth of a percent if necessary. So from 77 to 22, let me see if I can find a place to put my formula. I'll just put it for number one, and then we can kind of reference it for the others. So again, we're going to take the amount of change, divide by the original, and I'm going to multiply that by 100. That looks misspelled to me for some reason. And then we're also going to state if it's an increase or decrease. We can actually do this part right now without even finding the percent change by simply comparing the numbers. So it went from 77. So 77 is my original. And then 22 is the new amount. So the new amount is lower than the original. So this is going to be a percent decrease. I have to include that as part of my answer for number one. It's a percent decrease. Now to find the amount of change, I'm simply going to subtract 77 minus 22 gives me 55. And then I take that amount of change and I divide it by 77 because that's my original. Multiply that result by 100. And that's going to give me 71.428, and it keeps going. So I'm going to round to the nearest tenth. So I'm looking at the 4, the number next door, which is a 2, tells me to leave that for a 4. So here's my percent change, and it's a percent decrease. Number 2, we went from 60 to 73. So again, this is the original. You always assume when it's written in this format that the first number is the original. And we're going to use this formula here. We're going to take the amount of change, divide by the original of 60, multiply by 100. So in order to find the amount of change, I'm going to start with the bigger number this time, which is the new number. And if I subtract here, that's going to give me 13. I'll just double check my mental math here. I do indeed get 13, and I'm going to divide by 60 because that's the original number. So really important to note here, you want to go back to this problem to review what the original number is. A very common mistake my students in the past have fallen into is they'll look at the bigger number, and that's what they'll divide by, but that's not always the original amount. Remember, sometimes the new amount is higher, so we always want to divide by the original and then multiply by 100. So if I take 13 and divide it by 60, I'm getting a non-terminating decimal, so I'll wait to clear. So I'm just going to leave that answer up and multiply first. That's going to give me 21 point, and then the 6's just keep repeating. And if I want to round to the nearest tenth, the 6 next door tells me to bump that 6 up to a 7 and throw a percent symbol in my final answer. So go ahead and give numbers 3 and 4 a try on your own. Go ahead and pause the video, and you can reference what we did here to help you. And then when we unpause, you should see some solutions. Okay, here's what I'm getting as my answers, and hopefully we match. For number 3, we went from 78 to 85, so 78 is our original number. I subtracted and got a difference of 7. Remember, you always subtract so you get a positive, and divide that by 78. Multiply that result by 100, and I got 8.974, and it just kept on going. So if I round the nearest tenth in this number, the 7 is going to bump that 9 up to a 10, which will actually end up bumping the 8 up to a 9, and then the 0 comes from the 10 when we increase this 9 up to a 10. So this actually ends up rounding to 9.0, or just 9%. For number 4, we went from 47 to 30. Oh, and I just realized I forgot to do part of the instructions for a lot of these problems. And it's a very common mistake that a lot of students make. I forgot to do this here. State if it's an increase or decrease. You guys were probably wondering why I didn't do that for number 2. So for number 2, let's actually just go back real quick. We went from 60 to 73. This was a percent increase because the number went up. I'm glad I caught that. For number 3, we went from 78 to 85, so this is a percent increase. So that's also something that should be included in your answer. And then for number 4, we went from 47 to 30, so the number went down, so this is a percent decrease. And then that's what I'm getting as my percent decrease for a final answer when I round it. I'm getting 36.2. So hopefully now we match in its entirety, not just the percent change, but also whether or not it's an increase or decrease. And I believe that's my last slide, so we will end it here. Hopefully you found this helpful and not too difficult. Of course, if you have any questions, feel free to reach out, and I will see you guys next time. Take care.